Welcome to the pre-calculus video for chapter 3.2, part F. We're still talking about properties of logarithms, but today we're going to focus on continuous interest. So if you could put your name and period in your notes, that would be great. So these are formulas. The first two you've probably seen before, and they should be semi-familiar to you. The compounded interest yearly formula and the compounded in n amount of times per year. The one we're going to be focusing on today is this third one, where it's going to be continuously compounded. So the a is going to be equal to the p times e to the r, e to the power of r times t. Okay, so let's jump into our first question here. So Joe invests $4,521 in a retirement account with a fixed annual interest rate of 3%, compounded continuously. What will the account balance be after 16 years? So you want to write down the formula that you're going to use, and then see if you can identify in the questions what's going to be your principal, what's going to be your rate, and what's going to be your time. And then you're simply going to plug those numbers in and then punch them into your calculator. Okay, so the principal is the $4,521. The rate is 3%, so you're going to change that 3% to a decimal. So you're going to change it to 0.03, and then it's in the amount of years, which is 16. Okay? So you're going to say 4,521 times e to the power of 0.03 times 16. And so the only thing tricky here is following the order of operations, right? So to follow order of operations, you want to make sure you do the exponent first. So you're going to do e to the power of 0.03 times 16. You need to put that in parentheses in your calculator. If you're using Desmos, you can use the parentheses in there. I would hit equals or enter at that point, and then take that number and multiply it by 4,521. You will end up with $7,306.27. Okay? Next example is our friend Dan. He invested $8,769 in a savings account with a fixed annual interest rate of 4%, compounded continuously. How long will it take for the account balance to reach $12,000? Okay, so instead of giving us the time, they want us to figure out the time. Okay, so this is clearly the principal. Change your 4% to your decimal, and then plug in your pieces of your information. So the $12,000 is how much money you're going to end up with. So we want to know how long is it going to take you to get there, because that's how much you need to buy your boat or whatever. Okay, so the principal goes right here, and then you're going to multiply that times e to the power of 0.04, but t is what you want to solve for. Okay, so what do we need to do? We need to obviously divide both sides by the 8,769, and then we're going to take the natural log of both sides, and I move this over here, so I'm going to take that 0.04t exponent, move it out front, and if you type in the natural log of e in your calculator, you're going to get 1, so you can just rewrite that as 1 if you want. And then on the right, you're going to take the natural log of 12,000 divided by 8,769. And then the last step to get that t by itself would be to divide by that rate of 0.04. If you punch that all in the calculator correctly, you should get 7.84 years. This is going to take you just under 8 years to get to that amount. And the last example, sorry, went too far, is Joe invests $5,000 in a retirement account with a fixed annual interest rate, compounded continuously. After 9 years, the balance reaches $9,388.05. What is the interest rate? Okay, so this time we have to find the interest rate, so we're going to plug in the ending balance here, And here's our initial investment, which is our principal. And we know that it's 9 years. Okay, so we need to divide both sides by the 5,000. And then we're going to take the natural log of both sides. And then we're going to take that 9r and move it out into the front, kind of like a coefficient. If you type in the natural log of e into your calculator, you're going to get 1. Okay, so that kind of just simplifies to 1, and when you divide by 1, you get 1. So then you'll have on the right the $9,388.05 divided by the 5,000, and then the last step, just divide by the 9. So that means your rate is going to be 0.0699, all these 9s, okay? But we need to change that to a percent. So to change a decimal to a percent, you take the decimal point, you move it the other direction, so you move it 2 places to the right. And you could say 6.9%, but we're going to round it and say 7%. Okay?